All right, our last section is called Exploring Similar Solids. So we've already done a section where we had to determine if two quadrilaterals were similar. Okay, and so like a rectangle and a square are not similar because they're not the same shape. One's a rectangle and one's a square. Well, squares are rectangles. Very true. But this shape and this shape are not the same shape. So they can't be similar. They have to be the same shape, but a different size. Okay, so yes, these are both cylinders, and yes, these are both cylinders, but they're not the same shape of cylinder. So here, these two similar cylinders both got the smaller one got bigger in both height and width, and it stays proportionate to its original. Here, the cylinder got wider, but it didn't get any taller or shorter. So these two are not similar cylinders. Okay, so that's similar solids. Now, a common ratio is what the ratio is between the two similar solids. So let's say this had a radius of 2, and this had a radius of 10, then the ratio between the two figures is 2 to 10, or 1 to 5. Which means if I told you that this length here was, let's say, 6. Doesn't look like 6, but let's say it's 6. If this is 6, what would this be? Well, from here to here, it's 5 times bigger, so that's the 1 to 5 ratio. So 6 times 5 is 30. So the common ratio is if you divided the side lengths, they should all come out to be the same numbers or the same fraction. So 10 divided by 2 is 5, 30 divided by 6 is 5. That's their common ratio. Okay, now that ratio changes if you're dealing with side length, like I was here, or dealing with area, or dealing with surface area, or dealing with volume. And that's really what we're going to talk about today. Okay, so first question. Between these three cylinders, cylinder P is similar to, is it similar to A, or is it similar to B? Okay, let's look at the radius. The radius here is 3. The radius here is 9, so times 3. So that's a 1 to 3 ratio. The radius over here is also 9, so that's a 1 to 3 ratio. So far it could be either one. But then when I come down here, if the height is 5, 5 times 3 is 15, not 10. So the ratio between these, if I would have chosen this cylinder B, I would have done 3 over 9. That's the ratio of the radii, but the heights don't equal that common ratio. Those two ratios are not equal. Okay, 3 to 9 and 5 to 10 is not the same. This is times 3, this is times 2. Those are not the same, so this is not the shape. Okay, these two are similar. Okay. Okay, so first thing we'll talk about is right there, we just said that the ratio is times 3. It's times 3 for the sides. What about for the areas? Is the area also times 3? Okay, let's find out. The area and the surface area follow the same rules, so we're just going to talk about surface area. Okay, here is my work. I worked out the surface area of the smaller one and the surface area of the larger one. So we've just gotten done doing a lot of surface area. So surface area of the smaller one is 48 pi. If you want to check my work, you can. And the surface area of the bigger one is 4 32 pi. Okay, so the ratio of the side lengths is times 3. Is it also times 3 for the areas? Well, let's check it out. What's 48 times 3? It's 144. Is that what I got? No, I didn't get that. So it's not times 3. So what is it? Well, the other way we can figure this out is we can also divide to figure out, or we can keep guessing and checking. But let's go ahead and divide. So I'm going to take 432 and divide it by 48 to figure out what the ratio is. And it's 9. So the ratio from centimeters to centimeters was times 3. The ratio of centimeters squared to centimeters squared was times 3 squared. What about the volumes? Let's see if we can figure out volume. So the volume, again, I've worked these out already. The volume of the smaller cylinder is 45 pi. The volume of the larger cylinder is 1,215 pi. Now this would be measured in centimeters cubed. This would be measured in centimeters cubed. So is this times 3? No. Is it times 3 squared? Nope. It's times 3 cubed. 3 cubed, 3 to the third power, is 27. So if I take 45 times 27, I get 1,215, which is what I got here. So that's just to illustrate to you how the ratios work from side length to surface area to volume. Okay, so let's go over that again because it's probably not sunk in quite yet. That's a lot of information all at once. Okay, so let's go down to this example here. And we'll come back to this in just a minute. Okay, so the beach balls shown are similar with a scale factor of 7 to 6. So that's a 7 to 6 scale factor. Find the surface area and volume of the smaller ball, given that the larger ball has surface area, I should have given more space, 249.55, and volume 371.61. Okay, so I just read that from the problem. The surface area for the bigger shape is this, 249.55, and the volume of the bigger shape is 371.61. You have to find two things. So to find those two things, you need to do two separate problems. Okay, so you're going to set up two problems, one for surface area and one for volume. Okay, now what this box says up here is if you know that the ratio from the big shape to the smaller shape is 7 to 6, then for surface area, the ratio is not 7 to 6. It's 7 squared to 6 squared. How do I know that for sure? That's because the surface area is measured in 249.55 inches squared. So that had better match up. And now here is my x. Now I'm ready to cross multiply and divide. Now just so you know, this is inches squared. Do not put that inches squared into the calculator. It's just a label. So you're going to go 249.55 times 6 squared divided by 7 squared, or you can times it by 36 divided by 49. Okay, so we're going to cross multiply and get our answer for x. 249.55 times 6 squared divided by 7 squared, and I get an answer of 183.34. Is it smaller than the given surface area? Yes, and it should be, because we're finding the surface area of the smaller beach ball. And this would be inches squared. Okay, now you're ready to do volume. So the ratio of the side lengths is 7 to 6. But is 7 to 6 the ratio of the volumes? No. The ratio of the volumes is 7 cubed to 3 cubed. And why is that? It's because volume is measured in inches cubed. Okay, so that 371.61, that was the volume of my larger beach ball, so that's going to go here. And the volume of my smaller beach ball, which I don't know, will go right there. We cross multiply. 371.61 times 6 to the third power divided by, now I just got to caution you here as I'm typing this in, if you're using a graphing calculator, see how it's stuck up in the exponent? If you just hit the over button, that'll get you out of that exponent so that I can go divided by 7 to the third power. Okay, 234.02 inches cubed. Okay, that's part 1. Part 2. We're going to go ahead and flip back to the practice problems here and kind of do like one of each so that you get a little bit more time to feel comfortable with these problems. Okay, so the first 4 problems, it just says determine if they are similar solids or not. If so, determine the scale factor. Okay, so if we were doing the first one, you just have to make sure that the side lengths are all in the same ratio. So is 2 to 8, which is times 4, it's 1/4. Is that equal to 2 to 8? So far, so good. And then is that equal to 6 over 18? Well, is 6 over 18 times 4? No. So these are not similar solids. Okay. What about this one? We're going to go straight down to this one. What if there's only one number to compare? Well, then, yes, they are going to be similar. These will always be similar. And their ratio, or their scale factor, sorry, for this one would be 7 to 4. Those are the only numbers I know, so the only numbers I can put into my scale factor. Okay, going down to 5 and 6. 5 and 6 are similar to the ones we just finished up doing. Okay, so similar solid A is shown, and it's similar to solid B, not shown. The scale factor is from A to B. Find the surface area and volume of B. So we're this other one that's over here, it's actually twice as big. That's B. I don't know the surface area of B, and I don't know the volume of B. Okay, so you've got to set up two separate problems. Okay, I know my scale factor is 1 to 2, but I'm not doing the scale factor, I'm doing the surface area, and they are proportionate, but in order to do surface area, I need to take this and square them, because surface area is measured in inches squared, meters squared. So I need to square them for surface area. Now I can bring down the surface area. This is the surface area for A. So I'll put it up here with the scale factor for A. So it's 208 for A, and I don't know for B. Okay, so we cross multiply here, and then divide. And you can type this right into your calculator with the squareds in there. So 208 times 2 squared divided by 1 squared. Now I know dividing by 1 isn't going to do anything, but I just wanted to show it to you in the calculator. So 832 is the surface area of our larger shape B, and this is measured in meters squared. Okay, then when you go to do volume, the scale factor is 1 to 2. But when you do volume, you've got to take it to the third power, because volume is measured to the third power. So 192 is the volume of A, and I'm trying to find the volume of B. So this is for volume. And we're going to cross multiply. 192 times 2 to the third power. So 192 times 2, this is how I get to that third power. Use this little caret button on the side, remember? To the third power. Now again, you see yourself kind of up in that exponent, so hit over to get out of it. Divided by, and then you could do the other one. Obviously for us, it's not going to do any different. It's not going to do any good to divide by 1. But I'm just going to put it in the calculator to show you how it goes in. Okay, so final answer there is 1,536 meters cubed. Okay, last problem. Okay, so this one says find the scale factor. So when we found the scale factor before, we divided those two numbers to C. So we're looking for from 64 to 512 is what? Did you times by 2? Did you times by 3? Did you times by 4? Okay, so I'm going to take 512 and divide it by 64. And I get 8. Okay, that means the ratio here is 1 to 8. But that is the ratio of the volumes. Okay, so this is the ratio of the volumes. So if I want the scale factor, I need to know what number to the third power is 1. Well, that's 1. 1 times 1 times 1 is 1. Do you know what number to the third power is 8? Okay, if you don't know, let me show you how to find it. So to find the cubed root of something, okay, here's how you would find it. The cubed root of something is right here in your graphing calculator. So it's underneath the math menu. So you hit math, that's that third button down on the left side, so hit math. And the fourth option down is the cubed root. So the cubed root of 8 is 2. If you were going and using Desmos, it's a little bit more complicated. So how do you find the cubed root using your Desmos calculator? Okay, so under functions, let me slide this down a little bit more. Underneath functions, underneath miscellaneous. So you can go through, so there's your trig, your sine, cosine, tangent. But if you go to miscellaneous, right here it says n, and then there's a radical. So that button right there is how you're going to get the cubed root of something. Notice it's telling you you need to put a number up there. So we're doing the third root, the cubed root of the number 8. So I just tapped underneath there, and that's how you can get that on Desmos. Not as easy as your graphing calculator, but this is good for a lot of other things. Okay. Okay. Now, if you're doing surface area, so you can try that with this one, number 9. For surface area, when you do that division, so I'm going to take 108 and divide it by 75. Okay, and it comes out to be a decimal. So what you want to do is you want to get that into a fraction, which you can do that, remember, on your Desmos, or you can do it in your graphing calculator. So I can take that and you hit math, fraction. Okay, so that fraction there is 25 to 36. Okay, this is the smaller one, this is the bigger one, so 25 to 36. But again, that's the ratio of these surface areas. That's not the scale factor. So because this is squared, these numbers are squared, I'm going to square root to get the scale factor. So if I square root 25, I get 5. Square root 36, and I get 6. So that's my scale factor. On Desmos, remember, if you're dividing two numbers, you can get it to do a fraction just by tapping on the side there. If I do 75 divided by 108, okay, just by tapping in this circle here, right next to the number, it'll give you that fraction 25 over 36. Okay, so you have to cube root if you're given volume. You have to square root if you're given surface area.